In this episode, we talk about edge analytics and opportunities it provides for industrial automation. We discuss industrial edge analytics architecture and functional composition, and we also talk about industrial edge ML ops, crosser, and use cases of edge analytics in manufacturing. My guest on this episode is Martin Thunman. Martin is the CEO and co-founder of Crosser. He is a serial entrepreneur and executive with more than 20 years experience from deep tech and enterprise software. Martin co-founded Crosser in 2016 with the realization that low-code edge analytics, automation, and integration software will play a critical role for accelerating the digital transformation journey of industrial and asset-rich organizations. Quick thank you to our sponsors. This episode is made possible by our friends at HiveMQ, who are providers of an enterprise-grade edge and cloud-based MQTT broker, and Opto22, manufacturers of reliable industrial controllers for automation and IoT applications. So please do check them out to help support this channel. Welcome to the fourth generation podcast here on Industry 4.0.tv, which is a series of weekly interviews designed to help you learn industrial IoT from some of the world's leading practitioners. So make sure to subscribe and click on the notification bell to make sure that you never miss any of the interviews. If you find this conversation interesting, please review it with 5 stars on Apple Podcasts, follow on Spotify, and connect with me on LinkedIn at Kudzai Manditeresa. Now, here's my interview with Martin. Okay, Martin, thank you so much for joining us today. I would like to welcome you to the show.
Well, thank you, Kudzai. It's really a pleasure to be here.
Awesome. So today I want to talk to you about edge analytics for industrial IoT. Now, to begin, what do you see as being the major challenges in the integration of legacy systems with Industry 4.0 technologies?
Well, it's a very interesting topic, actually, one that I feel pretty passionate about. I think the automation industry is really not doing a great job here. I think it's an industry that talks with 2 tongues. They're definitely talking about being open and focusing on standards like OPC UA and others, but at the same time are still super protective of their legacy protocols and refuse to open up those specifications and letting other parties and their customer base, the whole industry, move faster forward. So in all honesty, I think the automation legacy vendors, and we all know who they are, they should be ashamed of what they're doing. That's what I feel about this. It's really a disgrace for all our efforts to move forward in this industry. They should just open it up, make everything possible for the customers to move faster forward. It's difficult as it is already.
Yeah.
We don't need that additional layer of just protecting their old assets. So that is a huge challenge for many of the customers of today. But at the same time, what we're seeing is modern technologies are coming out. It's becoming easier and easier for companies to connect to their machines. And there are solutions and vendors that have, of course, worked with creating bridge solutions between legacy and new for quite some time. So there are ways around it, but there shouldn't be ways around it. There should just be, great openness and working together. And I don't know if this is because big part of the automation industry is controlled by European vendors versus the whole internet and networking side more controlled from the US, where the US vendors tend to be much more open, focusing on standards. If we all share something, it will prosper. And that thinking is definitely not in the industrial automation space, but it could benefit from a different mindset for sure.
Okay, I totally agree there. So now, having said that, what would you say are the key requirements for industrial system integrators to move to what you call the next generation industrial automation solutions?
Yeah, so the starting point is always, data connectivity, as we just started the conversation here. However, one of the challenges and requirements to be able to do something intelligently with data is to be able to understand the data. So you have all of these machines, legacy and new, and they come from a variety of vendors, and the data formats looks completely different, dependent on protocol, dependent on vendor, dependent on sensor type. So just being able to transform the data and create a common data structure, I think is a very, very important starting point. I think as a software industry and technology industry, we're very good in creating hype. Currently, there's a lot of hype talking about machine learning and AI kind of being the savior of this whole industry. But without good structure, organized data, that doesn't work. So I think companies need to start from the bottom and create that data structure. And having the ability to do that in real time, distributed, has a lot of advantages. So that is a key requirement in our opinion. And another requirement, I think, is the human aspect of this. We have different team members with different competencies, and these modern use cases often involves the automation side, the IT side, but also subject matter expert. There are maintenance teams and others. So I think the ability to collaborate and work together and to solve and address these use cases will be very important. And I think in order for that to work, I also think that modern technologies need to provide much more of a intuitive, easy to use software based on basically low code or no code approach, which we're seeing in all industry segment, not only industrial, right? When the power of innovation is put in the hands of normal people, everything prospers.
Oh yeah, absolutely. Now, talking about machine learning and AI, now your company, Crosser, is all about edge analytics. So maybe just to set the foundation here for some of our audiences who are not familiar with edge analytics, could you define what edge analytics is and what opportunities it provides to the industrial automation space?
Absolutely. Let me first start with kind of the definition of edge, because that is a confusion already starting there. I think there are different ways of looking at the edge, but some talk about the edge as being the device itself. Others talks about the edge being sitting close to the device or to a machine. Others think that edge equals on-premise. Other things that edge is the network edge. So that means the service provider, the operators, telcos, they're talking about edge. For them, the network edge is something different than enterprise edge. So it's definitely a confusion here. What we do, we don't do device edge, but we do processing of data very close to where the data is being originated. So that means that what we wanted to do and what we saw very early on was that the trend that when we started the company 5 years ago, the trend back then was to go from, in the industrial space, pretty much everything on premise and move then everything to the cloud. And we had big industrial vendors, GE Predix and Siemens MindSphere. They were singing this song. We talked to a lot of industrial companies, and we could not see that flipping 100% from on-prem or from local data processing to going to the cloud we didn't see that scenario as realistic. We believe that there was a lot of benefit for having a layer where you process data between the origin of the data and cloud. But using the modern technology and the advantages of cloud. So that was our approach. So how can you take the best benefits of the cloud and then bring that to an environment where you process the data on your own infrastructure, whether it's a gateway that's on your close to your remote asset, if it's on a video camera processing images, or if it's on a factory floor, on a Windows server, or in VM in your data center, doesn't really matter. Basically, it's this layer of intelligence between the data sources and any other system. And the other system could be another machine. It could be an on-premise system. It could be cloud platforms like Azure or AWS, or it could be SaaS application. So that is really the notion. And the name Crosser comes from the notion of our software sitting in the crossroad of all these different data types.
Okay, yeah, this makes a lot of sense now. So, like, what's the possible opportunities there for like, say, manufacturing companies for going the direction of the edge? Do you have like some benefits that stand out for you?
Well, there are, of course, a number of drivers behind industrial 4.0 use cases and industrial IoT. Of course, on a high level of business drivers, all comes about how can we save costs and be much more efficient and move faster forward and being more competitive. Those are kind of overall business drivers, but then trickles down to become more technical use cases and technical advantages, and coming down to more digestible chunks. And one such obvious area is that there's a lot of savings to be done by not sending all the raw data to the cloud, by processing it locally. So there are immediate ROI for just processing it with intelligence locally. There are security advantages if you don't have to expose data to the internet. You don't do that. That's kind of rule one. Number one in security, you don't take risk if you don't have to take risks. So that's it. Another factor is latency. Of course, being able to take action on data close to the machine, you can bring down the latency, come down to just single-digit milliseconds in order to trigger action between automation endpoints. So those are some of the kind of immediate, more digestible use cases. But of course, there's all of this predictive maintenance and all of these use cases that we see and hear about, and the whole industry is looking at. But there are step by step. I think what we are talking to our customers about, that this is a journey. Industry 4.0 is not one project. It's thousands of mini projects that you need to do gradually, step by step, and you need to have very low incremental costs for each and single use case that you implement, whether or not that is transformation of the data, creating operational KPIs, doing calculations of data, or whatever the use case is, applying machine learning models for predictive analytics and so forth. Whatever the use case is, we believe that the most successful companies are the ones that don't start necessarily to solve one specific use case, but think about a layer that can give you this toolbox to solve 1,000 use cases, because that is where you ultimately will come to the position to be this fully digital and automated enterprise.
Oh, okay. Awesome. Now, to get a bit technical here, could you give us a breakdown of the functional composition of a typical industrial edge analytics solution?
Sure. I think there are, of course, all different use cases, and we have a couple of different types of customers. I'll place them in two main buckets. One bucket is machine builders that sell often industrial machines or equipment to customers in the field, and they want to make those digital and connected. So that is one customer category, and in that situation, the use case and the tech stack often is that you have the machine has the PLC, and this controller is collecting data from all the sensors that already is on the machine. That data is then transferred to an industrial gateway, some hardware that then runs an OS. On top of that gateway, there is an intelligent edge analytics software deployed. So the software is then deployed on a gateway very close to that machine or device, and processing all the data in real time as it is being produced, what is called streaming data. So processing that raw data, then doing whatever is needed. Typically, it's always data reduction, data transformation, creating that data model we talked about, then possibly aggregating the data. So sensors are creating and machines creating a lot of data, and that data is not necessarily always useful. So if you have a temp sensors that sends out, it's 90 degrees Celsius, so we're talking Celsius here, 90 degree, 90 degree, 90 degree, 90. You don't have to send all those data points to storage somewhere. You can then create intelligent rules that says, unless there's a change, aggregate this data over a time window. It could be 1 minute, 5 minutes, whatever you want to do. And then you reduce the amount of data tremendously. So that is just a simple example of that. You can't just aggregate it without looking for anomalies, because then you could potentially miss anomalies. So you need to be able to analyze the data before you create it, because if the data starts to the values start to go up or down, you might want to take some action based on that. And if you aggregate it, you miss that opportunity. So having that ability to smartly apply logic and business rules and different smart workflows is important. So and then typically for these remote assets for machine builders, the next layer in the tech stack is most often a cloud platform where they send for long-term storage, long-term analytics, and for visualization. If the machine builders have tight relationship with their customer, if it's a fixed installation, it's also not uncommon that there is local integration. So the edge node is then also connected to local systems. So the end customer also gets part of the data. So triggers can be created to the owner of the assets for further analysis or action if there is, for instance, an anomaly or something like that. The other part of the customer base, which is the factory floor, production site, there the tech stack looks different and it's much more complex. We talked about the legacy equipment, so you have all of these different type of generational machines and PLCs and protocols. Then you have the SCADA systems, you have MES systems, you have ERP systems, you have all other shop floor platforms and systems. So there it becomes much more, I would say, diverse and complicated. So that tech stack can look very different depending on the environment we're operating.
Okay. So, well, now having said that, we know in industry we've got some mature standards like the ISA 95. So when you bring that complex architecture into the picture, Does it create a conflict with this ISA 95, or does it complement each other?
I think the good part is with all the new technologies and all the new ways that this modern software can give companies is that they don't have to break up what they have already built. So this new tech stack can live in and complement the existing, and actually be like a horizontal real-time integration layer with intelligence that can communicate in an any-to-any structure between any parts of this ISO 95 reference architecture. So that creates a increased flexibility and agility for any production site to move faster and implement new use cases.
Okay, so you've already touched on the fact that having a uniform data structure, like data modeling, plays a huge role in building an intelligent solution. So do you have any best practices when it comes to industrial data modeling?
So for us, I think that is a great question. What Crosser put as an ambition when we started the company was to enable self-service. We believe in the power of existing teams, and we learned that there are so many different type of industries and companies and generational of companies, and many enterprises have grown by acquisition. So they've acquired companies that have different tech stack. There's never a homogeneous architecture, or it's a very rare that we see that. So therefore it's very difficult to have a generic standard for this. So we have built a self-service platform that the customer can leverage different components and building blocks that we call modules, and combine these modules in visual workflows in a way so they can be super flexible no matter what their environment is. This also comes back to the data model. The number of layers and dimensions in the data structure that companies might want to implement looks completely different, but we allow them to implement and enrich the data in real time. So not only can they, filter data or change names of properties, they can also add data and metadata to the sensor values in order to create that data model that they want to enforce. But I think many customers struggling with this just to create a common model top down. But when they do, it's a super powerful way for management, because all of a sudden they can get real-time insight into what's going on. So the level of analytics and insight they can get from a management layer increases dramatically if they can get to that common data layer.
Oh, okay, great. Now there's this concept called the Edge ML Ops. Could you tell us what that is and where it fits into the picture?
Yes. So I said earlier that we're good in creating hype, and ML is one of those areas, and where the starting point is kind of start from the bottom. But having said that, once you have created the structure, you have created this layer of intelligence between the machines and all of the other systems, you have the opportunity to do pretty amazing things. And if you want to deploy your machine learning model, and Crosser, as I mentioned, we provide a self-service platform. So we have a solution that allows the customers to run their machine learning model distributed. That could be basically in any location where they want to run that. So you come into challenges with the life cycle of of code of the model itself, but also about everything that happens before the model and everything that happens after the model, which are the part that we then have in our solution. So we have then built in different tools to centrally being able to create, have version control and ability to very easily distribute and redistribute models into the field. So we're doing, for instance, one research project with Scania trucks. This is a public case, so I can talk about it, where the challenge is that if they run machine learning model in the trucks, in distributed in, can they cover tens of thousands or hundreds of thousands of trucks, and have multiple models, and they collect new data, send it up to a central location, retrain the model, and then need to redistribute the model. How do they do that, take care of that life cycle management in a good, efficient way? And that is the tools that we have built around this challenge that allows customers to update the model, create a new version, and boom, one click, redistribute that model out to the field. Because historically, one of the challenges and disadvantage of edge has been that the cost of managing that infrastructure has been, very high. So that's where the centralized cloud approach is coming. But what we experience and what we believe is that the architecture of the Crosshair solution is that we have this management layer, which is cloud-based, and we have this distributed runtimes, the analytics engine that runs wherever the customer wants to deploy it in the edge. That combination actually gives the customer the best of two worlds: the central management and the modern feel of cloud technologies, but the security and the low cost of processing the data in a distributed fashion. And ML, of course, is part of most companies' roadmap. There are very few customers that we talk to that do not see that as a part of their future roadmap.
Okay, that's awesome. Makes a lot of sense there. Now, as far as the hardware is concerned, are there any special requirements for hardware to run edge analytics?
Not really. I think in our case, there just need to be an OS that can host Docker containers or Docker. So as long as Docker is supported, you can run a Crosshair Edge node. We run on small gateways, low cost with low cost processor. We can run on Raspberry Pis. We can run on even smaller than that. We did some benchmark performance tests on a Raspberry Pi. We can process up to 8,000 messages per second. So it's a very fast analytics engine. On a normal server, PC server that you might have on the factory floor, we can process over 100,000 messages per second. So it's very fast. You don't need a lot of hardware to run edge analytics, but you do need it to have the ability to run Docker. With one exception, we do some of the manufacturing production sites have standardized so heavily on Windows. So we also have the ability to run the software, our runtime, as a Windows service. So that's also possible. We would recommend Docker because of the increased management capabilities and lower cost over the life cycle. But many enterprise IT departments have very strong, they're used to deploy software running Windows services. They have all the tools needed for that. So that's often not a big deal for them. So both is possible, but the requirement of the hardware is not that high, unless you want to run a lot of vision, high definition video streams. Then the requirements become a little bit tougher. But we have partnerships with camera vendors, and where we run actually where they have an OS and a processor on the camera, and we actually run inside the video camera. So there's no gateway even needed for that. So that is pretty interesting development.
Okay, yeah, that's interesting. So now you talked about the ability of an analytics system to be able to collect data from things like your PLCs, your ERPs. What specific connectivity technologies does Crosser support?
So basically, this industry it's a very long tail industry, but it's a kind of as in many cases, it's an 80-20 rule at least. So we support the big ones. We support OPC, UA, we support DA, we support MQTT, HTTP, Modbus, we support Siemens S7, we support Rockwell, Allen Bradley, we support CAN bus and a couple of other protocols and PLCs as well. So normally we work with the customers on their project. If there is a missing piece, then we normally just develop that module. But so far, most of what we see in the market is kind of within that range. That's often the starting point.
Okay.
So that covers a lot, and then of course any REST APIs that is out there we support, and yeah, I think most of the customer requirements we support today. So the connectivity is there for the base, but then when there are niche legacy equipment, then we come into this discussion we had earlier, and there we always have a conversation with the customers regarding, if they want to use a converter. There are tools in the market and software in the market that are specialized on just doing protocol translation that have much more legacy drivers developed over many years. Sometimes customers use that to kind of bridge that, and then we get OPC UA or MQTT from those kind of the protocol translators.
Oh, okay, that's interesting. Now, seeing that this industrial data typically comes from like a variety of sources, some report by exception, some are being polled. So this data, it's sort of like there's lack of uniformity there in terms of the time of updating and also the connectivity technology used. So what mechanisms does Crosser have to sort of manage this data in preparation for the analytics?
Yeah, so there are different way to do that. We have this building block that I mentioned before that we call modules for doing a lot of data transformation, changing properties, changing the structure. We can split up arrays and create common structures so it's all look like messages. The powerful structure of the Crosser architecture is actually such that whenever the data comes in, we transform it into a internal format. So which means that we can take any format in, transform it, then deal with the data in a consistent way and manipulate the data in any way we want. And then in the end of the flow, the customer then decides what format and where do they want to send this data. So they just basically use those modules, and the data then being sent to the next system that is in the tech stack. So Crosser, we do only real-time data processing, what we call data in motion. We don't store data. We can buffer data if there's connectivity issues, but we don't do long-term storing. We don't do long-term visualization that you normally see in more like broader industrial IoT platform. But we're this middle layer that can work with any industrial IoT platform, and we can offload them. We can offload the MES system. We can offload the ERP system from a lot of this data. So there are different tools to split data, change timestamps, and align timestamps. some ML models, for instance, they're built from tabular data because that's from file tabular data. But then in the streaming world, as you're alluding to, the data is coming in a different order. Yeah. So we have basically a module that takes that streaming data, align the data so it's for the machine learning model looks like a tabular format. Yeah. So we kind of change the timestamps and push it into the next module, which is then could be a machine learning model. So that is also available. So there's a lot of different tools that we have developed together with our customers to facilitate this. There are modules for counters, for calculating OEE metrics. So that's something also that is becoming more and more requested, because customers are seeing the benefit of having real-time insight, not only from the machine data, from the sensors, but also from the PLC statistics, like counters of how many times, how much, and volumes and counters. So, and also being able to do that over time, creating OEE calculations. So we have all these methods to be able to do that. So it's as I said earlier, it's a toolbox that create this flexibility for the customer for themselves to implement a big variety of different use cases.
Okay, awesome. Now, you mentioned that a lot of manufacturers see machine learning as being crucial to their digital transformation strategy, so to speak. What do you see as being the common use cases when it comes to edge analytics?
Yeah, I think we've touched upon many of these already. Creating this common data structure is one. We talked about data reduction, just lowering the cost of cloud, offloading the cloud platform, both from a cost perspective, but also from a performance perspective. Being able to, one thing that we haven't talked about is creating machine-to-machine automation. So without having to go through, maybe there is a niche use case where they don't want to go in and have a big development project in their MES to create this new automation machine to machine. They can use systems like Crosshair to do that. So we can also write back to PLCs. So we do that. Customers are using that for different type of use cases. So that is commonly being used. Vision, quality inspection is another use case. Also for other using cameras as advanced sensors is definitely coming more and more. Historically, manufacturing companies have been using vision systems a lot, so there's nothing new for manufacturers, but they have been closed. It's been a black box solution. The vendors have come in, they've provided the camera, gateway, analytics modules, dashboards, etc. It's been a siloed vision solution. With the cost of IP camera that has dropped so dramatically, customers then seeing that that they can basically decouple that vertically integrated vision solution and take a standard off-the-shelf camera, apply software like Crosshair on that, add a vision AI model for detecting anomalies, and then creating triggers based on that. A trigger could be stop the machine, send a message to the HMI for the machine operator, or it could be sending a SMS to an engineer or anything else. So being able to act on that, create act. Talking about legacy, vision could be used. One company we talked to, they had a legacy machine that was completely non-digital, but it had a red and a green lamp, and they had a process where an operator had to go every 30 minutes to check if there was a red or green lamp and tick that off on a box. So instead, they put a camera and just film that red and green lamp and put a small algorithm on that and a trigger, so they could just reduce that kind of manual process of going and manually check that red and green lamp. So there's a variety of areas, large and small, where vision sensoring can make sense, and it now the cost of this has been driven down and more accessible with open AI. That's also again coming from the US, driven by the internet companies pushing openness and on these algorithms. So this is great for everyone. So that's another use case that's coming, but also integrating other systems, integrating the MES system with the ERP, integrating with other shop floor platforms. Could be lab equipment, can be whatever other software tool that you might have, but also horizontal integration between the production site or the shop floor and more the top floor businesses and business systems are becoming more and more common as well. So the most successful project that we see are the one that starts where the companies wants to take an architectural approach to this. They don't take a use case approach, but they think, okay, what if we apply and put in this intelligent edge layer in our tech stack? What could we do with that? And they can see all of these different opportunities, and then they start by implementing one use case after the other.
Oh, okay, that's interesting. Now, at the beginning of this talk, you mentioned how the industry is resistant to change, for many different reasons. So now, what do you see as being the future of low-code platforms in IoT?
Yeah, I think if you look at the market for developers today, there is about 1.5 million job openings in the world currently. Do you believe that number is going to be lower in the future, or do you believe that number is going to be higher in the future?
Yeah, it's certainly going to be higher.
Yeah, it's going to be higher, right? So that means that it's going to be tougher and tougher for enterprises. It's tough for us. We're a hot tech company. We have a hard time finding good software developers, and everyone have that challenge. So also, if you're an industrial company, you definitely have that challenge, both recruiting and retaining your top talent. So building in code has the disadvantage with that is just becoming larger and larger. So the advantages with having platforms that hides the complexity of writing code and puts the power to existing team members, existing operations, OT teams, automation engineers, maintenance teams, data scientists, and you have IT personnel, to put the power to innovate in their hands using drag and drop and pre-built modules. It gives not only the power to innovate to individual contributors, but it also gives the ability for bridging the OT IT sides together. Because often when we build these flows, the start point of this flow where the data input is the domain of the OT teams. Then you go through some type of data processing. That could be the data science or the data engineers, data analysts that are in charge of that part. Then you have the last part is often creating the workflows and actions based on the different analytics piece. And who are in charge of that? That's often the IT teams. So all of a sudden you can have 3 or 4 different team members contributing to the same workflows and doing that in a visual manner, so everyone can see visually what the other team members have contributed with. It's a game-changing effect for companies and for teams, both the way they can move faster, but also how they can collaborate and work faster as a team, no matter if they are on the same site or if they are on multiple sites.
Oh, okay. Yeah, I totally agree. I mean, there's a large number of manufacturers out there are small to medium enterprises, and most of them, they really can't afford to have like an in-house cross-functional team, So yeah, totally agree there. Okay, now in conclusion, could you tell us more about Crosser, the company?
Absolutely. So we're a Swedish company. We come from outside the automation industry. We have been doing enterprise software, enterprise hardware, big scale project for service providers, and we saw that the industrial side have a lot of challenges ahead of them. And we came into this industry with a fresh mind. So we're a Swedish company, but we also have a team in Germany. We are working with systems integrators and automation specialists. We're teaming up with them. We're working very closely with also the rest of the tech stack. So we have decided to be the best on the planet on the intelligent edge layer for edge analytics, which means that we also become very partner friendly because we only do this. So we're partner friendly with everyone that are doing hardware and OS and hypervisor layers. And we're also partnering with whatever other system that come northbound. It could be MES systems, ERP vendors, it could be IoT platforms, it could be cloud platform, and so forth. So we're partnering up with the objective every time that if we can do things together, we can again lower the barriers for the end customer and make the journey smoother, easier, and less costly and less painful for them. That's always the objective for us. We're fanatical about simplifying things for our customers, and I think that mindset has been also brought in here because we come from outside the automation world. We see that the automation industry is they've accepted a lot of the complexity, whereas we come from the outside and say, well, how can you accept this complexity? There's a possibility to remove this complexity and hide this for users and make it accessible for more people to innovate. So that's where we're still a venture-backed company. We have leading Scandinavian, German investors, but also Asian investor. We have NTT Docomo Ventures, the big telco out of Japan, is one of our investors, for instance. So we have a strong group of investors that is behind Crosser, and also that sees that opportunity for a company that taking the best of the cloud technology, but applying that on the edge. That has a great potential in the market. We have customers pretty much all across the world, and the customers that are running deployment in factories in multiple geographies, deploying this. Some customers deploy, one factory, many use case. Others start with one use case, many factories. So it all depends on the end customer, how they deploy.
Okay.
So that's a bit about us.
All right, awesome. Okay, so that brings us to the end of this session. Thank you so much for coming through to share your insight with us. We wish you all the best.
Well, thank you, Kutsai. It's been a pleasure to be here, and I must say that you're also doing a great job for this industry by bringing all people together and sharing your podcast. So thanks for doing a great job on that.
Okay, thank you. Thank you.
All right, cheers.